Okay, so hopefully third time's the charm, because Athena's wanted to crap out of me the first two times. So, I'm going to do a quick tutorial on how to use Athena to process APS data. So first thing I'm going to do is open up Athena, and we're going to quickly go through the steps on how to do Athena processing of APS data. So first and foremost, you can break it down into a few easy steps. We're going to import our data. We're going to inspect the data to make sure it looks good. There's no beam damage, there's no corruption of the data files. We're then going to merge our data. We're going to align our data. And then we're going to use our data and the data on standards to do linear combination fitting on our samples. We then export the data and we're off to the races. So we'll do a super quick and dirty version of this, just going through all the steps super briefly. And if any more clarification is needed, then I'm sure you can go from there and either find me or someone else who knows what they're doing and go through it. So right off the bat, we're going to go to File, Import Data, and we're just going to grab some data files. So to make things easier, I have it in a folder by date, and we're just going to scroll down and just make things easier. I'm going to grab SOC16 and hold down Control and grab all the files for SOC16. And while we're here, we'll also grab all the files for a wash water. We'll do wash water 27. We're going to open, and it's going to bring up a channel with the different channels we're going to use. So at this point in time, you probably see this little blinking area down here. We're going to click that, find where our Athena plot is, and drag it out. So this gives us a little preview of what our data is going to look like. So we want to select the proper channels for our sample and our reference and import them. So we're going to scroll down here and see what each of these things mean. And whenever we're importing data, we're going to import channel 10, which is our sum, over channel 5, which is our pre-KB IO. So I'm going to grab that, and that looks good. I'm then going to import our reference channel, which is 5, which is pre-KB IO, over 8, which is IREF. So importing those together, we'll be off to the races. If you're doing silver, where your sample and your reference foil are identical, then you're off to the races. You can click OK. If you're doing arsenic, where your sample, which is arsenic, and your reference, which is gold, are different, you're going to want to uncheck same element and go from there. But I'm doing silver, so I'm going to check it. I'm going to click OK. So it's going to go through and it's going to import all my files. If you've got a really good computer, you can do this in huge batches and import it and go through. If you've got a crappier computer or you're working off of an ESG computer or an office computer, it's going to be a little bit sluggish, so I recommend doing it in batches of 3 or 4 samples, merging them together, and then deleting the raw files that go into it. But I'll show you how to do that in a little bit. So I've imported all my data. I'm just going to quickly check off all my data for one file, hit E. Purple E shows me all my data at once. I could show the raw version of it, or I could show the normalized version of it. The software itself does a pretty good job of normalizing the data. If you see some bit of curvature going on up and around this area right here, or this area isn't quite flat, you can use these pre-edge and normalization edge data points to kind of adjust and fix where necessary. But this looks pretty good. So because it looks so nice, I'm then going to go merge, norm E. I'm going to merge my file together, and I'm just going to name this SOC16 merge. I'm then going to uncheck it, scroll up to the top, check off my references, and just get rid of those. Clear up some space. I'm then going to check off my next sample, hit E, and you can see right here we've gone from really good data to really crappy data. So this is from a silver sample that was very low in concentration, but we're going to zoom in and see what we can do. So if you're looking at the noise right here, you can kind of see some areas where it looks like there's some patterns that kind of goes up, then comes down, goes up, then comes down, goes up, then comes down. And these patterns we can actually work with. We actually want to capture this. But this red and this green right here is probably going to throw it off a little bit. So what we're going to do is we're going to merge it and see how it looks. We might uncheck 2 and 3, or red and green, and see if we get a better merge. And actually, yeah, we're going to do that right after that. We're going to uncheck 2 and 3, re-click E, and that looks much better. You can see this is more clear. We can see the patterns more nicely. So now that I have that, I'm going to go to merge, norm, and it's going to give us our merged file, which we're going to call washwater 27. Hit OK. go through and delete these files. Okay, and now we have our two data files, which look pretty good. So they look pretty straightforward. You can see our sock, which has a high concentration of silver, probably a few thousand ppm, really, really strong. Our wash water, which is probably 10, maybe 50 ppm, not so strong. So now we basically do the exact same thing for the rest of our data and our standards. I already have a project file sitting off to the side that we're going to quickly use just to save ourselves some time. So I'm just going to grab a few quick standards that I know are going to be in here. So I'm grabbing nitrate, I'm grabbing oxide, I'm grabbing nanoparticulate, and I'm going to grab both these chlorides because I can't remember which one is the good one. I'm going to import all my selected data. So at this stage of the project, you should have all your data. I'm just going to save up this file quickly. You should have all your data and it should be merged together. At this point, we now need to align our data. So we've imported our data, we've inspected it, we've merged it, now we have to align it. So to do that, we align the reference channels with each other, which will then correct the main sample. So I'm going to go to Align Data, and I'm just going to pick any of my references to use. So I'm going to use my SOC 16 reference. I'm going to go off of that. I'm just going to left click on the reference channels of each of these. As you can see here, these don't match up. I'm going to click Auto Align, and now they do match up. I'm basically just going to go through and do that for all of them. You can see these two references don't look the same. These were taken at different times and on different APS lines. So the data looks a little bit different, but you can still align it pretty well. Just going to auto align that, auto align that, auto align that, and auto align that. So our data looks pretty aligned, some of it better than others. We're going to save this file up and go back to our main window. So now we've imported our data, we've inspected it, we've merged it, we've aligned it. Now we get to linear combination fitting. So we're going to linear combination fitting. The reason we saved previously is because sometimes this freezes up the software, and it looks like it's going to do it again here. So if it freezes it up, then we just kind of close it off and start from scratch. Let's see, Athena, there we go. Okay, so file, import, where did we save it? There we are, test. So we're going to re-import all those files, and this is a great little example to do if the software crashes, because it will. You just import your project file and you're off to the races. So, I'm going to linear combination fitting. I'm going to click the file I want to basically fit my data to. I'm going to select up to 4 standards that I think could be in here. So because of what I did to the sock, I basically took the sock and washed it in a chloride solution with artificial sweat. There could be nitrate, there could be oxide, there could be nanoparticulate, and there could be chloride. So I'm going to pick all those 4 samples, and I'm going to click Fit All Combinations. So once again, this is a sock that I've washed in water. And I do the fitting, and it spits out this. It says right off the bat, could be nitrate, oxide, and some nanoparticulate. But I'm going to take a look at my other options and see what this could be. Because we can kind of see over here, the first part looks great, but this fitting over here doesn't quite look fantastic. I'm going to see if I can zoom out a bit. This area here, right here doesn't look the nicest, so let's take a look through. Here we get a little bit better, telling it it's a little bit of that. If I go here, it's getting a little bit closer, so even though it's not matching up perfectly, the features are matching up a little bit more nicely. And now we get to a kind of place where we have to make a decision, so it's really hard to say. We can kind of see from here, it looks like it's going to be mainly nanoparticulate. I'd say this probably, let's see. This one looks pretty good, which says it's some silver oxide as well. But it could also be some chlorination going on. I'd probably go with the silver chloride for this one. 83% silver nanoparticulate, and about 16-17% silver chloride. Although I might go back here and change my chloride standard and see if I can pick up something different. So let's see if that makes it a little bit nicer, kind of petering through a little bit. We're still getting about the same things. This looks a little bit nicer now, 85% nanoparticulate, 7% chloride, 7% nitrate. I'd probably go with this. Might even go like that. That's probably nice too. A little bit of a gap between here, but the peaks and valleys line up appropriately. So then, if that's the data I'd be happy with, I then go to standards, save fit as column data, and then you save it as an LCF file, which you can then process later using Excel. So we've done that. That's a really nice, clean, easy to do sample, and even that was kind of tricky for silver. Now we'll go on to washwater 27, which we saw previously was a pain in the ass. So we'll grab nanoparticle, chloride, oxide, and nitrate, and let's see what happens. Fit all combinations. It's going to ponder and think and ponder and think. And it's going to give us a really crappy fitting right off the start. Biggest takeaway here is it's giving us a negative value for chloride. If it gives you a negative value, you know it's going to be wrong. So it's going to go through, and this looks pretty good. Again, there's a bit of a gap here between the fitting, and this is just most likely due to the difference in energies. Because our standards are all very high in concentration and our sample is very low in concentration, there's going to be a bit of a difference in the normalized absorption. Even though it's trying to normalize it, it can only do so good of a job normalizing it. We can see here our peaks and our valleys kind of match up pretty well. I can kind of click through here, and there's a few different examples of that, but it's all about the same. So I'd go to standards, and I'd save fit as column data. One of the important things here, because it's saying that it's mainly nanoparticulate, I can go back to the main window and just check washwater 27 and check our nanoparticle and hit E and see how they line up. And we can see exactly what's going on here. They line up pretty much perfectly. So this looks pretty close, if not identical, to what nanoparticulate would be. And it's just this little gap right here that's not quite catching. And depending on your nanoparticle standard that you used, you might get better results with this. We've got a few different ones, so let's quickly grab those and see if we can get something a little bit better. So even though all the nanoparticles and everything that you're using should be the same, it should be identical, sometimes it's not. Sometimes you have some that are a little stronger, a little weaker, and we're going to re-import these new standards and see what's going on. And when you re-import new data, you have to go back and align it. So checking our reference right there, we're going to align that, checking that right there, we're going to align that. Okay, so back to the main window. Let's check off our 3 nanoparticles and our wash water. Click E. And you can see right here, some of them look very similar, like purple and red, which is nanoparticle and nanoparticle normalized, from 2 different times and 2 different operators actually, look pretty similar. The green, which is the 30 nanometer, looks a little bit higher, and the blue is the lowest. So the biggest takeaway here is that even though these are all identical samples pretty much, there will be variations between run to run. But you can see here, this clearly looks like nanoparticulate. Sometimes in situations like this, it's an effect of the normalization going on. And let's see if that's the issue here. So if I go over here, let's see if I can fix the normalization and have it normalize up a bit nicer. So what I'm trying to do is I'm trying to bring this bottom end up a little bit. And it doesn't seem to want to do it. So sometimes it can be a little bit stubborn. It doesn't quite want to raise itself up too much. Let's see if I check flatten. No, that didn't do anything. So in situations like this, I think what's going on is that it's the background it's applying is just screwing things up a little bit. And yeah, so if I normalize that, that looks great. So let's see if that fixes it a little bit. Okay, so that brings it up. That brings it down. So I want to kind of go somewhere in the Let's try that now. So let's check that off. And let's see how that looks compared to everything else. Normalize it. Oh, beauty. So we can see here the normalization's actually fixed it really well. And it now brings it really close to this 30 nanometer. So let's go back to our, let's save this first. Let's go back to our linear combination fitting. And let's pick those standards again. And it always happens. Like I've saved all this data. I'm ready to, put this data in my paper. And now, of course, I figured a better way to do it. And this will happen a lot of times. You'll be going through, as you get closer to the end of the data, you'll realize, oh crap, I found a little trick or a little bit of a better way. But let's fit this quickly. And let's pick an option that doesn't have it. Let's see. So it's really crappy now for some reason. What's going on here? Before we had a really good fitting. Now it's looking really crappy. Hold on a second. Something's gone weird here. So linear combination fitting is flattened mu e, so it's flattened it out a bit. It looks okay. I'm curious as to why it's looking a little funky now. So this is an example of sometimes you overwork the data a little bit. And even though we clearly see as day that it is indeed nanoparticulate. Okay, this is a little bit better. That's not bad. Even though it's clear as day, it's nanoparticulate. Sometimes because of how close it is, it doesn't quite like it, and it doesn't fit it too well. But I would say that's a pretty good fitting for the data right there. And then, yeah, so it says here it's mainly nanoparticulate and a little bit of nitrate, a little bit of ionic silver, which makes sense. Yeah, so there you go. So that's how you do that. Again, you go standards, save fit, and I'd save it as. If you're ever curious, or if you ever think something's screwing up, you can just, like I did before, just display the different things and just visually take a look and see what's going on. And we can see right here, clear as day, that this is pretty much nanoparticulate silver. Like it's pretty obvious. If you want to get really fancy, this is a bit advanced, and this is the last thing I'll show before I finish this up. You can actually check the merging based on the derivative. And to do that, you click here and fit all combinations. And this is something that's really helpful for really messy data, and it'll fit the derivative of those different peaks. And you can see it kind of gives you some better results. It kind of changes things a little bit. Depending on how noisy your data is, it can make it sometimes worse, like it's doing here. But it sometimes works, sometimes it doesn't. Like if I did it with SOC 16, for example, which I'll do right now. So we'll go that, we'll go that, we'll go nitrate, we'll go chloride, fit all combinations. Oh, did I do derivative? Yes, here's derivative. You can see here it gives you a really great strong fitting with a very strong chi-square value. You can kind of plug around a little bit and have it figure out what it could be. But for the stronger ones, more people just use normie, so it's just the better thing to do. And you can fit it based off that, and you can see right here, it looks like a fantastic fit. We're getting really strong, really strong results that indicate it's mainly nanoparticulate. There you go. Alright, awesome. So that's the little tutorial. I hope it didn't run too long, and that should help you get through and have a good idea as how to do Athena.